So, for my project, I made a musical cellular automaton, and the actual logic of how the automaton works is very simple. So I'll explain that later. But first, let me explain the arrangement of this grid. Well, okay. So the way this hexagonal grid is laid out is that every vertical step is a perfect fifth. So CG is the fifth. For those of you who know music theory, CG is a fifth, or GD is also a fifth. And every diagonal step in this direction is a major third. And because of the beautiful cyclic properties of music, you do a fifth, 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 and then a fifth down from A will take you to E. But I just chose to draw the E like up here. And so fifth, 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 and you do it 12 times, and you go back to F, and then you go back to C. Right? So it's kind of it's a torus or something. I'm not sure what topologically the shape is, but it wraps around like this. And similarly, if you do third, third, and if you do a major third up from A flat, where do you end up?
C.
C, exactly. So this wraps around this way, and it's I think it's interesting. Well, no, you don't end up at C. You end up at D flat. You end up here, right?
Oh yeah.
So no, wait. So if you go A flat, B flat, you end up at D flat, right?
I'm not sure.
You do a major third, you say?
Yeah, major third.
So it's like I have to count. No, it's C, right?
You end up at C, right? Okay, yeah, we're good. So, so you wrap around this way. So this is major third, and then this wraps around this way. So I'm not sure what topologically this space really is, but it's an interesting arrangement. And let's make some sounds just manually, right? And so you can see that a perfect fifth is very consonant. It sounds good. And similarly, a perfect third is also right? And so any triangle that you draw of this shape is always going to be a major chord. So similarly, let's try a different major chord. Anywhere else you can start, like, here. Or let's say, that's again a major chord, because you have to remember that going a perfect third, a major third this way ends up with G. So this is a major. Similarly, if you do a triangle of this shape, it's a minor chord. All right, so that's that. And so then the rest of this was just basically I was prioritizing the roles of the automaton to keep these triangles alive as solitons, and keep these vertical things alive as perfect fifths for consonants. And anything that's dissonant or anytime there's too much going on, it should kind of kill the cell. So let's see what that sounds like. So I just set it up with some initial, let's say, a triangle. And I was quite happy because this is surprisingly musical, right? Typically, it's very hard to get these computer-generated music things to sound nice. Similarly, if one triangle can stay alive, what happens when there's two triangles? And now it's playing variations of a seventh chord, and the seventh chord travels across the board. All right, enough of that. What if we do something that's really like dissonant, right? I don't know. So another property I observed. This is not something I programmed, but it's like if you do I'm not sure what the name of this chord is, like an augmented fifth or something. Augmented fifth. Anyway, this is kind of dissonant, but like in a creepy way. If you run this, it just kind of stays. Yeah. Okay, so that's the basic like the first layer. And then I thought, okay, well, another thing you do in music is you have different voices that are progressing at different rhythms. So the blue you saw, I mean, you got a preview of this when I was clicking twice. The blue is one species that moves at this rate, and then I did a second species, which is yellow, and yellow moves at half the tempo. And if both species are occupying the same cell, then of course it turns green. Right? And let's see what that sounds like. If you wait long enough, they overlap. Yeah, see, and now they're perfectly together, and then again it starts a cycle of like 12 or whatever the least common multiple is until they overlap again. Yeah, so that's that. I don't know. Does anyone want to suggest a starting pattern, and we can see what it sounds like?
Maybe a vertical line to see what happens.
A vertical line, like how many? How many do you want?
Let's say 3, yeah.
So it just stays. So it's
Okay.
a stable.
Okay, I see. Can we destabilize it in some way?
And then it prioritizes these triangles.
Yeah.
So I mentioned before.
So there are 2 rhythms total, right? The yellow and the blue.
Yeah, and it could be very easy to add more. It's just
Right.
a matter of copying, adding another instance of the thing that controls the board. Yeah, and I don't know if you want, you can step manually. It's really hard to get things to sound musical. I did the best that I could. And if there's too many things playing at once, let's see what happens, right? This does not sound good at all. And so most of them die, and it kind of stabilizes into something that's better. So it always likes to end up with these traveling major minor chords. The one with a lot of things on? Okay, so the first step kills most things. And those two lit up because they were neighboring like this and this, I think. And so they thought that, so basically every cell tries to say, in the context that is around me, would I be adding to the consonants if I turned on or not? And that's sort of what I tried to code into this. And so those two thought they would be adding to the consonants, and then one step nothing. And then this one says, oh, if I come in now, it's better. And then A dies because A does not have any neighbors when G and B are active. It's all out, so A is like, there's no point of me being active. And then now D sees that, okay, it would be nice for me to also be active. And then the triangle starts.
So are the rules completely symmetric, or
No,
is there a bias?
There's a bias. As you saw, like triangles move downwards.
Yeah, exactly.
I could have done the opposite bias, but there is a bias.
Okay.
And similarly, yeah, I had to make some decisions at multiple points. So I could have prioritized, major chords versus minor chords. Or I could have.
Yeah.
It's not very principled right now. Basically, I played around with the rules until I got some nice dynamics. But the rules didn't end up being too complicated.
Can you start with the diminished chord?
Sure. What do you want?
C flat, G flat.
C.
C flat is like B.
No, C, E flat, G flat, C diminished.
Right. C. E flat. E flat. Yeah. Oh, that's interesting. Now it landed up in this stable configuration. That's pretty cool.
How about a diminished 7? add A also?
This is pretty cool though. I mean,
Yeah, I think these are all diminished 7.
all dimensions. The same way that we had like augmented fifth traveling, I think the diminished sevens also travel the same way. Yeah, that's it. Thank you.
Questions?
I have a suggestion. Maybe you can add some, like, you can change the rule over time. So that would be like some sort of modulation.
Yeah. Yeah.
I mean, now diminished 7s are stable, but maybe if you have a different set of rule, only majors are stable or something like that. So it can modulate somehow.
Or some sort of mutation thing that goes on, like after one whole iteration of all the patterns, it changes the rule randomly, and then you have a different pattern for the next iteration or something like that. Yeah. Another thing I was thinking of doing was, what other dynamics can play out on this hexagonal grid, and we saw some hexagonal simulations in class, like the diffused gas model or something. But the problem with many of these is that if you're simulating a diffuse, like a gas diffusion, you're going to end up with everything is active at a low level everywhere, which is not musically very good. For something to sound musical, you specifically want things to travel and different pieces to be active at different times. So I was trying to think of what could be a good fit.
Question. So between the two kind of speeds of evolution,
Yeah,
so are the interaction between them completely decoupled or they are coupled?
completely decoupled. They
Okay, I
evolve
see.
completely independently.
I see. So maybe that, probably it will be more too chaotic if you start coupling them, but it
Yeah.
would be interesting to see.
Yeah.
Because in this case, most of the dynamics kind of converge quickly to something periodic, right?
Yes.
Okay. I was wondering, so do you play music? Because you have some knowledge about these.
Yeah, some music. Yes.
So what do you play?
I sing mostly.
Okay.
I've been singing for a long time, and
Okay.
I know the basics of a few different instruments.
Yeah.
Most the same. Yes.
So in music you have this, I mean mostly in classical music you have this notion of tension and resolution if you have seventh chord, right? Do you have any idea how this rule of this can be implemented or?
So initially, I was trying to get this to play like the classic chord progressions, right? Like 1, 5, 7, 4, or whatever that sort of stuff, and the 4 chords that can play every song or something. And I was trying to plot out what those chords look like on this grid, and they do have some regularity, but it's not at a per cell level. If you have to look at the whole grid and evolve the whole grid. So it didn't fit neatly into this, like each cell updates based on the state of its neighbors.
And what about instead of having the individual notes, you could have like a cell is like a chord, and then it goes.
Right, exactly. And then, but the only thing I could play is major chords and minor chords, right? Because each triangle, like this triangle is this major chord, this triangle is this minor chord.
Yeah, but if instead of C you have C major, and then next to it you have a C minor, and then next to it you have a C major 7, or I don't know what.
Like each cell is a chord itself, instead of being a note.
Right, but then you'd have to be careful to preserve this sort of symmetry. Like the one obvious way I see of doing it is to say instead of this hexagons as I've drawn them, these are my nodes. This one and this one and this one. So these are all chords. Right? This is D major. This is B minor. This is D major, and that's my hexagon. But I'm not sure how you would fit in, like, augmenteds and diminished and whatnot into the same sort of grid pattern.
So here the dynamics are local on the hexagonal grid. So each cell can see the cells around it. Is that correct?
Yeah.
Okay. And the specific dynamics, is it too boring to explain, or it's? So do you think there is?
I can show you the dynamics.
So these are the dynamics that you found that produced the nicer kind of musicality, or there were others which were okay.
dynamics are 0 if none of your neighbors are active, then turn off. If only one is active, then preserve your current state. Let's skip this for now. If too many of your neighbors are active, then turn off.
Okay.
And then the interesting parts are for if only 2 of your neighbors are on, or if 3 of your neighbors are on.
Okay.
And then basically I did a bunch of case analysis on, okay, is my 5 neighbor on, is my 6 neighbor on,
I see.
etc.
Okay.
Yeah. So I think this is kind of boring to explain.
Yeah, no, of course. I
But
was
this
just
is
wondering.
this is the whole logic.
Okay,
This is what you should
okay.
modify to get different neighbors.
Okay. Questions? Yeah, one last. Yeah.
Another suggestion. Maybe you can also add the second octave as different notes, so it doesn't loop on it.
Yeah.
Because
But then when you stop it, then you keep going up and up and up and up, and you just
I mean,
kind of
after the
vanish.
second octave, it can retain. Because I mean, ninth chords are there's specific chords that use the notes in the other octave, which
That's true.
add
That's
to
true.
the richness.
I think so. The way I programmed the synthesizer right now doesn't make it sound too bad.
By the way, this runs in a browser, right?
Yeah, this is all browser.
So I could put it on my website afterwards. Very nice.
Not too bad, right? Like the D is actually playing both octaves. Each cell is playing both octaves. Because if you play only one octave, it does sound off, exactly as you said. So to make it sound as nice as it does right now, I had to do some of this synth manipulation. Yeah, my other interest is in electronic music, so I was playing with the synths and stuff.
Any last questions?
Yeah.
Maybe you can modify the rules to follow some kind of musical theory instead of just spatial relationships.
Yeah, exactly, and I think that's the same thing you were saying before. And to do that, I think you need to have a global view of the grid rather than individual, like local behaviors.
Or even add some microtonals to make it more analog.
Uh-huh.
Instead of,
Yeah.
Okay, thank you.